In this video lecture, we will study about various binary tree traversal algorithm. Traversal means how you can visit all the nodes of the binary tree. So traversal is a process to visit all the nodes of a tree and may print their values. You can either print the values or you can process the values stored at the binary tree nodes. So in the traversal of the binary tree, you will be visiting all the nodes of the binary tree in some order, and while visiting the nodes you can process the node values. That is, node values means the information is stored at each node of the binary. Okay, so since all the nodes are connected, okay, via edges or branches or links, okay, branch is a general term. In fact, the line connecting two nodes is called an edge. It may be called branch. Okay, it is also called link. Okay, branch is usually used in the discussion of the graphs. Okay, so, a tree or binary tree can be seen as a subset of the graph. In the graph, we also have nodes, and we have edges or branches connecting nodes. Right. So the difference is that there are no cycles in the binary trees. Also in trees, there are no cycles. Okay, but there might be cycles in the graph. Okay, and we have a root node, left subtree and the right subtree, while there is no such thing in the graph. So we will be discussing the graphs also later in this unit. Okay, so the point I want to mention here that in the tree all the nodes are connected. In a graph, we can have unconnected component. Okay, we can have two nodes in between which there is no path in a graph. But in a tree and in binary tree, in fact, all type of trees, if we have two nodes, we always can find a path from first node to the second node and from the second node to the first node because all the nodes are connected, right? So since we know that all the nodes are connected in the tree, so we can search for a path from a node to any other node of the binary tree, right? So now how we can traverse the nodes of the tree and binary tree. Here in this discussion, we are focusing only on the binary tree, right? So we are just focusing on the traversal of binary tree traversal of binary tree. We are not talking about the general tree now. Okay, so there are three ways which we use to traverse a tree: in-order traversal, pre-order traversal, and post-order traversal. Okay, generally we traverse a tree to search or locate a given item or key in the tree to print all the values it contains. So the purpose may be different depending on the application. Okay, so pre-order, in-order, and post-order, these are three traversal algorithm, right? So say you have a binary tree. Here A is the root, and this is the left subtree of root node A, denoted by LT, and this is the right subtree of the root node A, denoted by RT. Okay, so in pre, in, and post order, okay, the root node, the left subtree, and the right subtree are traversed. Okay, these three steps belongs to each traversal algorithm. That is, you will be visiting the root node, the left subtree, and the right subtree. These three steps are processed in each of the traversal algorithm. Okay, but the order is different. You will traverse the root node, you traverse the left subtree, and you traverse the right subtree, but in different orders. Okay, and in, for example, in pre-order, you process or visits the root node first, then you visit the left subtree, and then you visit the right subtree. Okay, but in the in order, you visits the left subtree first, then you visit the root node, and then you visit the right subtree. And in the post order, you will visit the left subtree first, then you will visit the right subtree, and then root is visited in the last. Okay, so you can see that all these three algorithms have the same steps, have the same number of steps, three, and all those three steps are also same. That is visiting the root node, visiting the left subtree, and visiting the right subtree. The only difference is the order in which they are visited. In the pre-order, root is visited first. Okay, that's why it's called pre-order, because root node is visited before the left and the right subtree. Okay, so it is called pre because it the root is pre-processed, pre-visited before the left and the right subtrees. Okay, you can also notice one more thing, that the order of left and the right subtree, the order of visiting the left and right subtree is same in all the three traversal algorithms. In pre-order, left is processed first, then right. Okay, and in order, left is processed first, then before the right. And in post order, left is processed first before the right subtree. Okay, so the order of left and right subtree is same in all the three. Okay, the only difference lies with the order of the root node. If root node is visited before left and right subtrees, it is called pre-order. If root node is visited between left and right subtrees, it is called in order. Okay, and if the root node is visited after both left and right subtrees, it is called post order. Okay, so that's why they are also called NLR. That is, the pre-order is called N and R. N is for the node, L is for the left subtree, and R is for the right subtree. So node means here the root node. The root node is visited first, then left subtree and the right subtree. Similarly, in order is also called L and R. That is, the left subtree is visited first, then the root node N, and then the right subtree is visited. Okay, and in the post order, it is also called LRN. That is, the left subtree is visited first, then the right subtree, and then the root node is visited in the last. Okay, so in this example, so for the pre-order, what you will do, you will be visiting and processing the root node. Okay, so the content of the root node, the information part of the root node here is A. So for example, the task is just to print the value stored at each node. So you will print the value of uh, root node, value stored at the root node, which is A. So it will be printed. Then you will have to go to the left subtree. Okay, so this is the left subtree. Okay, now what will you do? Okay, this is a complete subtree. Okay, a subtree is a complete tree. Okay, so what you will do, you will process this subtree in the same way this whole tree is processed. Okay, and how you have processed this tree? The root node, then the left subtree, and then the right subtree. Okay, and each of the LT and the RT is a complete binary tree, so they can be processed in the same way as the processing of the entire tree. So A, then LT. Okay, LT is this tree. So what we'll do, you will be processing this subtree in pre-order. So in the pre-order, root is processed first. The root of this subtree is B, right? So let's put brackets to distinguish this subtree from another subtrees from RT. So B, and then the left subtree of this node. Okay, and the right subtree is this node will be traversed next. So these cases are simple because the left subtree of node B contains a single node. So we can directly write it. Okay, similarly, the right subtree also contains a single node, right subtree of the B, and that node is node E, right? So this is the traversal of this subtree. Okay, LT. Now traverse RT. Okay, so this subtree, the same way you will be visiting the root node of this subtree RT first. It is C. Okay, then the left subtree is empty, so nothing will be visited, and then you will go to the right subtree of node C, and right subtree contains a single node, so you will just print this value. Okay, you can remove these brackets. So A, B, D, E, C, F. This is the pre-order traversal of this binary tree, right? Similarly, you can print the traversal of in order and the post order traversal algorithms, right? So here you can see that these definitions are recursive. Okay, to traverse a binary tree in pre-order, you traverse the root and then you traverse the left subtree and the right subtree. And how to traverse the subtree? In the same way as the original tree, as the main tree is traversed, right? So these definition of pre-order, in order, and post order are recursive. Okay. Now let's see these algorithms one by one. First, pre-order traversal. The pre-order traversal of the non-empty binary tree is defined as visit the root node, then traverse the left subtree in pre-order, and then traverse the right subtree in pre-order. Okay, so we traverse the left subtree in pre-order, then we traverse the right subtree in pre-order. And what is pre-order? It is here recursively defined. The pre-order is this. Okay, that is, you will be visiting the root node of the subtree first, and then you will visit the left subtree of the first subtree, and then you will visit the right subtree of the first subtree in pre-order. Okay, so let's see another example how you can print the in order traversal, sorry, pre-order traversal of this binary tree. Okay, so first the root node is traversed. Here the root node is A, so you write A. Okay, then you traverse the left subtree in pre-order. Okay, so in pre-order you traverse the root node first. The root node here is B, so you just print B. Then traverse the left subtree of this B. Okay, in the pre-order, after traversing the root node, you traverse the left subtree. So after traversing B, you will traverse the left subtree of B. Now left subtree, in the left subtree of the node B, the root is D, so D is traversed next. Okay, then you traverse the left subtree of D. The left subtree contains a single node. Okay, so you will traverse H. Okay, so in fact you can also assume that H also has two nodes and those two nodes are null. Okay, and H will be the root of that subtree, the root of the left subtree of node D. So you will traverse H, the root node of that subtree, and then you will be traversing the left and right subtrees which are empty, so nothing will get printed, right? In the same way, you will traverse the right subtree of node D. So I is the root node of that subtree, and left and right children are both null, so nothing will get printed. Okay. So in this way, the left subtree of node B is entirely traversed. Then you will go to the right subtree of node B. Okay. So right subtree contains a single node, so you simply write its value E. Okay, then there is no left or right children for node E, so this entire left subtree of node A is traversed. Okay, so node A is traversed, and after that its entire left subtree is traversed. Now you will go to the right subtree of node A, the root node A. Okay, in and this right subtree will also be traversed in the pre-order. So in the pre-order, the root node of the left right subtree is traversed, which is C. Okay, then you will traverse its left subtree F, single node, and then you will traverse its right subtree, the single node, right? So this is the pre-order traversal of this binary tree. Okay, let's check A, B, D, H, I, E, C, F, G. Okay, pre-order is also known as depth first order. Okay, why depth first order? Why depth first order? Right. Uh, pre-order is also known as depth first. What is depth? Depth is the distance from the root node uh, to the leaf node, to the farthest leaf node. Okay. So depth means you are going down from the root node to the leaf node. Okay. So you can see that here you are traversing from root node towards the leaf node, towards the leftmost leaf node. This is the root node, and the leftmost leaf node is this node H, right? So you are going down from the root node towards the leftmost root node. So node A, then node B, then node D, then node H. Okay, see this A, B, D, H. The first four visited nodes in the pre-order traversal of this binary tree are these A, B, D, H. Node A, then B, node D, then node H. Okay, so it means that you can print this branch of the pre-order traversal of this binary tree just going down from the root node, traversing the leftmost branch down to the leftmost root node, A, B, D, H, right? So since the depth is covered in the pre-order traversal, it is called depth first search or depth first order. Depth first search, in fact, is a search algorithm which is used in the graph algorithm, and it uses the same method. That is, you will be processing the leftmost branch first, going down from the root node to the farthest leaf node. So it is also called depth first search order. Okay, sorry, depth first search algorithm. Here we are discussing the traversal algorithm. It is called depth first order. So pre-order is also known as depth first order, right? So in fact, this can be used as a trick. Okay, so what you do, you just start from the root node, traversing down to the leftmost branch. Okay, then you go to the root node, and then you go down from that node, traversing the branch. Okay, okay, then you go in this way. Okay, and then traversing all the nodes in this path in this way, right? And you just draw this dotted line. Okay, and you print the values of the all nodes encountered during this path. Okay, if a node has already been printed, then you will not be printing its value. If the node is getting traversed for the first time, you will print its value. Okay, so for example, in this binary tree, you just draw this path in this fashion. Okay, and then follow this path. So first you will found A, so you will print its value A. Okay, then you will found B, so print its value B. Then you will found D. Okay, print its value D. Then you will found in this along this path you will found E, so you will print its value F. Then you will found F, so print its value F. Then again you will found E along this path, but since E has been printed already, so you will not be printing its value. Then you will found, in fact, you can extend this path like this. Okay, okay, so they haven't shown this dotted line along this, because B and A has already been printed, so they will not get printed again. So but if you draw like this, so after E you will find B again, but since B has already been printed, so it will not get printed again. Then A is found again, since A has been traversed, so it will not be printed again. Okay, then you will find C for the first time. Okay, so you will print C. After that you will found G, so G will get printed. Okay, then you will found H, H will get printed. Then J is found. Next node traverse is J. After J you will found L along this path. Okay, then you will found J again. So J has already been considered, so it will not get printed. Then you will found H again, it has already been traversed. Okay, then you will found K. Okay, so this is the pre-order traversal of this binary. Okay, so using this trick you can very simple, you can print the you can print the pre-order traversal of a binary tree in a very simple way. You just draw these lines traversing all the nodes, or you can also say traversing all the branches of the binary tree like this. Okay, and then you write then you move along this path, and then you keep writing the nodes uh, as they encountered on this path. Okay, and you will be printing the value of that node only for the first time. Okay, if you encountered that node for the second or the third time, you will not print its value, because it has already been considered and gets printed for the first time. Okay, the root node, here the root node is encountered three times. Okay, first time, okay, then second time, and the third time. Okay, in fact, along this path, when you are going up from the rightmost node to the root node, up to the root node, okay, you will found all the nodes has already been traversed. Okay, so there is no need to draw this portion of the path, right? So this is simple trick using which you can just print the pre-order traversal. Okay, this is the pseudo code of pre-order, and in fact this is the actual code in C language. Okay, can be used as a pseudo code. So this is the structure of the binary tree node. Okay, here the node value type is character. Okay, then you have the left pointer and the right pointer, and this is the method or the function. Okay, for the pre-order traversal you pass the root node. Okay, so here in this example, okay, this is the root node, and root node pointer is this. Okay, this is the root node pointer. The pointer stores the address. Okay, so the address of this node is 200. Okay, so at the root node we have stored 200. Okay, and at location 200 we have this node, and the structure of the node is we have three different values: the data, left, and the right pointer. So data is here, data in the root node is f, and the left pointer is the 150, right pointer uh, is 350. Okay, that is the address of the left subtree is 150, address of the right subtree is 350. Address of the left subtree means the address of the root node of the left subtree. Okay, so this is the left subtree, and the root node is this one, and the root address of this is 150. So here 150 is stored in the left position of the root node f, right? So using this algorithm, you can simply traverse this tree in pre-order traversal. Okay, the code is very simple. If root is equal to null, if the binary tree is empty, then simply return, nothing will get printed. Otherwise, print the data is stored at the root node. So data here is characters, so percentage %C. Okay, and then you will traverse the root left in pre-order. Okay, that is the left subtree will be traversed in pre-order. Okay, so remember the pre-order function. Okay, in the pre-order function you are passing the pointer to the root node. Okay, so when you traverse the left subtree or the right subtree, you will be passing the root of the left subtree or the root of the right subtree to this function. Okay, so here in this statement you traverse the binary tree in the left subtree of the root node in pre-order. So to the pre-order function you will be passing the root node of the left subtree, that is the root left, this pointer. Okay, and then you will traverse the right subtree of root node f. So pre-order and the root right, that is the pointer to the root node of the right subtree. This is right subtree and the root node of this right subtree is node j and its pointer is this, that is the address 350, right? So the algorithm is very simple. The recursive algorithm is very simple. If you are asked to write the non-recursive algorithm, then obviously you will have to use stack. Okay, because in the non-recursive version you must use stack so that you can remember which node which node have already been and processed and in what order. Okay, so L-4 order is usually followed. Okay, so you can also write the in order, pre-order, and post-order traversal algorithms using stat non-recursively, right? The recursive algorithms are very simple. You can see the code is also very simple. Okay, but the non-recursive will be more complex because you will have to maintain explicit stack and you will be specifying when to push or pop with the node values from that stack. So the algorithm will be more complex. Okay, so for each of the traversal pre, in, and post order, you can also write the non-recursive algorithms using stack. In fact, this is to be done in the assignment. Okay, in a day or two, I will be giving the assignments, and the one question will be this. That is, you will be implementing. In fact, you will be writing the algorithm. You will be writing the non-recursive version of the pre-order, in-order, and the post-order traversal, right? So this is the pre-order pseudocode or the actual code in-order traversal. Okay, this is the algorithm of the in-order traversal. That is, you traverse the left subtree first, then you visit the root node, and then you will visit the right subtree in order. Okay, so here you traverse the left and right subtrees in order. Okay. So example for the same tree that we have considered in that pre-order traversal, we try to find its in-order traversal. So what is the in-order? In the in-order traversal, you visit the left subtree first, and then you visit the root node and the right subtree. Okay. So this is the right. This is the binary tree. E is the root node. So in the in-order traversal, you visit the left subtree first. In-order is also called L and R. Left subtree, then the root node, then the right subtree. Okay. So from the root node, you will go to its left subtree. Okay. You will reach to the root node, but you will not print its value. Okay, because the left subtree is printed first. So from the root node, traversing this left branch, you will go to the left subtree of the root node. Okay, and then this left subtree will be traversed in the in order. Okay, the root node of this binary subtree is node B. Okay, in the in order, you will traverse the left subtree of node B first. So from the root node B, you will go to this left subtree. Okay, then again the same procedure will be adopted. That is, from the root node D of this subtree, you will go to its left subtree, which contains a single node edge. Okay, Now from H you will go to its left subtree, which is empty. Okay, so traversing the empty binary subtree is very simple. You will not print anything. Okay, so here you obtain, you encounter null. Okay, in the left subtree of node H you have null, so you will print its value, means you will not print anything. And then in the in the order traversal, after visiting the left subtree, you print the root node, left node, right. So after visiting this null node, you will print the root node value, which is H. H will get printed. Then the right subtree of H, which is also null, so nothing will get printed. Okay, so this traversal of this subtree, which contains the only node H, is complete. Okay, so it means that the left subtree of node D has been visited. Now you will visit it. Now you will visit node D, the root node of this subtree. Then you will go on visiting the right subtree of node D, which contains a single node I. So you will visit in the same way as node H was visited, right? So HDI, this left subtree of node B has been visited. Now we will visit the root node B, okay, root node B of this subtree, okay. So after visiting the node B, you will visit its right subtree, which contains a single node E, okay. Now this entire left subtree of the root node A has been traversed, okay. Then you will visit the root node A, and then you will visit the right subtree of root node A, okay, in the in order. So in the in order, again you will go to the right subtree. Okay, in the right subtree, to traverse it in the in order, you will first traverse this left subtree. Okay, so left subtree of node C contains single node F. Then the root node is traversed. Root node, the right subtree is node C, and then the right subtree of node C is traversed, which contains a single node. So let's check it. S D I B E A F C G. Okay, so this is the in order traverse. So left subtree is first in the in order, then the root node, and then the right subtree is traversed in the in order. Okay, so this is the pseudo code. If root is null, then simply return. Otherwise, traverse the left subtree in order root left, and then print the root node, and then traverse the right subtree in the in order. Okay, the recursive definition. Okay, so the same way you can use the in order traversal algorithm. Okay, the post order. In the post order traversal, the order is different. That is, you first traverse the left subtree in post order, and then you traverse the right subtree in post order, and then finally you visit the root node. Okay, so let's see how the post order traversal is printed using the same example. Okay, so first first the left subtree, then right subtree, and then finally the root. So root comes in the last. You can see here A comes in the last. Okay, so left subtree first. So left subtree is a complete tree. So B is the root node. So again you will traverse the left subtree of the root node B. This is another subtree. Okay, so you will be traversing the left subtree of node D first, which is H. Then its right subtree, which is I. Then the root node, which is D. Okay, now left subtree of node B has been traversed. Now you will traverse its right subtree, which is E. Then the node B itself. Okay, so this is the left subtree of root node A. Then you will traverse the right subtree of node A in post order. Okay, again we have a root node C of this subtree. The left subtree contains a single node F. Okay, right subtree contains single node G, then the root node of the subtree C. Okay, and then finally the root node A. Right. So this is the left subtree traversal, this is the right subtree traversal, and this is the root node. Okay. So this is the post order traversal. Okay. So if root node is null, return. Otherwise, traverse the left subtree in post order, then traverse the right subtree in post order, and then traverse the root node by printing its value. Okay. So there is another trick to traverse the tree in post order, and that trick is uh, second time. Okay, the trick is that you draw the same path as we have drawn in the pre-order traversal. Okay, in fact, this path is not visible, clearly visible in this figure. So, let's see, where is this figure? Okay, let's draw this on this figure. Okay, so this is the root node. You draw this path. Okay, right. So what you do for the in-order traversal, the trick is that when you find a node along this path for the first time, you don't print its value. But when you find that node for the second find, then you will print its node. So a node is printed when it is found for the second time along this path. Okay. So for example, F, you will start from here. Okay. You encounter node F first, so it will not get printed because it is found for the first time. It will be printed when it is found for the second time, right? Then you will find node D for the first time, then node B for the first time, then node A for the first time over here, right? So again, since node A is encountered for the first time and also it is the last time also, and if it is if a node is found for the last time also, okay, and because the first time and the last time for that node is same, it will get printed. Okay, so here you will print A. Then you will find node B. Now node B is found for the second time. So you will print node B. Now node C will be encountered next, and it is encountered for the first time and also for the last time. So it is also gets printed. Then you will visit node B again for the third time. Okay, but we have already printed its value, so it will not be visited again. Then you will find node D for the second time. So you will visit node D. Then node D is node after node D, you will visit node E. Okay, because it is the last time for the node E. Okay. Then node F is encountered and it is encountered for the second time. So F is visited. Okay. Then node J is visited for the first time. So you will skip it. Then node G is visited. Okay. And G is visited for the first time, so you will also skip it. Then I is visited for the first and for the last time, so I will be printed. Then node G is visited for the second time, so you will print its value. Then node j is visited for the second time, so you will print its value. Then node k is visited for the first and the last time, so you will print its value. Okay, so this is the in order traversal trick. Okay, so here you can see that f is the root node, so whatever to the left of this is the left, it is the in order traversal of the left subtree, and whatever at the right side of f is the in order traversal of the right subtree. Okay, so you can check. Okay, so for example, the right subtree. Okay, so here the left subtree is empty. Of left subtree, the node G is empty. So you will simply, uh, you know, F. You will simply I then G. Okay, and then you'll traverse K. Left, then the root node, and then the root node is T, then I is that. Okay, there is some issue over here because what we have done, before I, node G is visited. Why? Because the node G is encountered second time over here. Here the left subtree is empty. Okay, so what you will do when you encounter this empty left subtree, okay, and then you move along this path, so node G is visited for the second time over here before going to the node I, right? So node G is encountered here for the second time. So node G will be printed before node I, and then you will go to the node I for the first time and the last time, and then I will be printed. Okay. So this is the trick for in-order traversal, but there is an issue because if there is some empty left or right subtree, you must also consider that. While there is no such issue in the pre-order traversal trick. Okay, in the pre-order traversal trick, you don't need to check for the empty left and right subtrees. But in the in-order traversal, if you are using this trick, then you must also consider the left and the right subtrees which are empty separately. Okay, and while traversing along this path, when you find the node for the second time, you will print its value. Okay, and if a node is found for the first and the last time, you also print its value. Otherwise, you will skip that node. Okay, the order of leaf nodes. Okay, you can see that in all the three pre-order, in-order, and post-order traversal, the order of the leaf nodes are same. Okay, so for these three, these are the pre-order, in-order, and post-order. You can check that the order of all the leaf nodes D, F, G, L, and K are same. Okay, that is D, F, G, then L, and then K. Okay, that is D, F, G, L, and K. This order among all the leaf nodes is in pre, in, and post order. That is D, then F, then G, then L, then K in order. In post order also D, then F, then G, then L, and then K. The order of all the leaf nodes are same in all the three traversal algorithm: in order, pre order, and the post order. Okay, you can also, binary trees are also used for expressing the algebraic expressions. Okay, if you use binary trees to express or to represent the algebraic expressions, then you will notice an important property, that is the in-order traversal of that binary tree which is being used to represent the algebraic expression will be same as the infix notation, that is the infix expression or that algebraic expression. And if you traverse the binary tree in pre-order, you will find its prefix notation of the algebraic expression, and if you traverse that binary tree in post order, you will get the postfix notation of that algebraic expression. Okay, for example, this is the binary tree, and this binary tree is the binary tree notation of this expression. Okay, and obviously this expression is in fixed notation. Okay, so if you traverse this binary tree in order, you will get this infix notation of this algebraic expression. If you traverse this binary tree in pre-order, you will get the prefix notation of this expression. And if you traverse this binary tree in the post order, you will get its postfix equivalent, postfix notation equivalent of this algebraic expression. Okay, so if you have if you are using binary tree for the representation of the algebra expression, then you can very easily find the infix, prefix, and postfix notation of that algebra expression by traversing in order, pre-order, and the post order of that binary tree respectively. Okay, header nodes. Like in the linked list, we can also have header nodes in the binary tree. Okay, so we have a special header node in the binary tree. So we name it as head. You can name anything to that header node. Here in this example, we are using head. So we have a pointer variable head, which points to the header node. Okay, so this is the pointer variable head pointing to the header node. The left pointer of the header node points the root node of the binary tree. Okay, this is the binary tree, and this is the root node of the binary tree. So the left pointer of the header node points to the root node, and right pointer points to null. Right pointer is pointing to null, does not point to anything, right? So what is the use of the header nodes? Header node stores summary information. So information part may store some summary information like number of nodes in the binary tree. Okay, so here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 nodes, so you can store this value 11, the number of nodes in the binary tree, in the information part of the header node, right? So any summary information can be stored in the header node. The left pointer of the header node points to the root node of the binary tree, and the right pointer does not point to anything, it points to null. Okay, there are other uses of header nodes. Header nodes can also be used as the sentinel. Okay, so sentinel means a special value. For example, if you don't want to use null values, because sometimes in the programming the null values may produce some errors if they are not handled properly. Okay, so if you want to avoid those kind of errors, you can remove all kind of uses of the null values. Okay, instead of using the null values, you can use the sentinel values, and header nodes can be used as the sentinel values. Okay, because here the null values are basically the null pointers. Okay, so instead of pointing to the null, you can store the address of the header node over here. Okay, so it means that any node, okay, which points to the null will be pointing to the header node. Okay, instead of pointing to the null, they point to the header node. So if at any node you point a pointer to the header node, it means the left subtree or the right subtree of that node is empty. Okay, for example, you consider node E. Okay, here